Hey everybody, welcome in that new video tutorials which shows how to use the Unreal Blueprint to control Golem public attribute within the Golem engine. That tutorial concerned especially simple values such as integer, float, boolean, and that kind of stuff. And there's going to be another video for vector, free arrays, and the more complicated compound attributes. So I'm running Golem 8 and I'm having a simple scene of a grid of characters walking, and what I would like to do is something really kind of dumb, which is I want to control the scale, min and max of my character based on some objects within Unreal. But that's just a practical example to show you how you can use the blueprints to do this. So within the entity type, we've got two attributes called scale min and scale max, and those guys allow to control what's going to be the scale of my character, the ratio scaling of my character. So if I change the value for 2, for example, I can see I'm having character twice bigger than what I had before. So the first thing I want to do is expose those attributes, so they will be converted as public attributes and they will be controllable within the Unreal Blueprint. So for this, I can go within the crowd manager. I'm going to isolate my entity type node, which is here, and I'm going to find my scale min and scale max attribute that I'm going to check. We can see that those are floating values, so those are simple values, and that tutorial will apply for every single simple attribute that we have here, like uint 32, float, string, etc., etc. So let's apply this. And let's export my scene as a Golem digital asset. So here we're going to serialize the scene as a GDA file which contains the public attributes and all the asset files which are going to be used here. Let's jump into Unreal here and let's create a Golem simulation node. Make sure that you create it at 0, 0, 0, else the characters will be offsetted. And I'm going to bring my scale blueprint GDA here. If I play the sim, I've got exactly the same sim than within Maya. Now let's take those guys here, my cube max and cube min, to control my scale min and my scale max. So let's scale that guy, the cube max, to a scale of 2 on the x-axis, and that one here of a scale of 1 on the x-axis too. Here within the Golem simulation, we can see that we've got two Golem float properties, so as public attributes that I can expose and check. So I'm having one which is the scale min set to 0.9. I'm gonna say that I want to override that one here, so it's a floating value here, so we can see it into the interface. It's a GDA float property. And here, that one here is the max value. Once again, we're going to say we want to expose it and override it, and it's set by default off at 1.1. If I put a value of 2 here, and I can already see within the viewport my characters being influenced by this. And if I go back to 1.1, now I've got my characters having a different size. So if your attribute is something which you know from the beginning, you can just override it from the panel. If you want to use some specific objects in your scene to control that attribute, so maybe the scale is not the best example, but once again, that's just a use case to maybe give you ideas for other attributes to control. So I'm gonna go into the blueprint here and I'm gonna open the level blueprints. So as always, probably the first thing I want to do is take my cube max and have a pointer to it, take my cube min and have a pointer to it as well, take my Golem simulation because I'm gonna override one attribute of this as well, and bring those in. So let's see in terms of the Unreal system here how I can get the scale from my cube max. So I can just type probably scale here, I think. And I've got a get actor scale 3D, which returns us with a vector, and I can break that vector to only get the first attribute of it. So that's my cube max scale value here. And I want to do something similar for my cube min, so I'm gonna take and do exactly the same stuff here. and also break the vector to be able to grab only the first value. So yeah, we're good. In terms of the Golem simulation, I want to be able to find a property by short name. So the property I'm looking for is my scale mean and scale max. So I'm going to copy them from here as they are overwritten. I'm going to copy it here, and I want to probably create another one which will allow me to let's, I think it's fine, yeah, my short name here, and here I'm gonna fill it with scale max value, scale mean, scale max. Great. So those are gonna return a Golem property here. So Golem property is is all that stuff there. So what we want to do is well, that's gonna return a generic properties, and what we need to do is to cast that properties as a floating value. We know that those are float attributes, but that GDA property by short name just return the pointer. So we just need to cast this to a floating value so we can operate with floating attributes. And also maybe I want to take this into account in debugging play. So let's probably create a sequence here. Okay, so a sequence just allows to just sequence my two actions. So first I'm gonna fetch my scale mean and override it. Then I want to fetch my scale max and override it. Great, now we're good. So let's convert this as a floating attribute. So once again, I can type GDA here. And thanks to the context sensitivity here, we can see that we've got a list of options of what we can do. And here we can cast our property to a float property, or int32, int64. So those are exactly the same type that I just showed you within the GDA public attribute within Maya. Here we know that we are casting this as a float property, so that's great. And let's do the same here, float property there. Okay, and now we're having something which looks like this. So we're having a GDA property which is composed of a value, of a short name, full name, a dimension, size, array size, override data type. So it's a compound, and what we need to do is say that we want to set the value of this. So I'm gonna check, well, I can type, I guess, GDA once again, and from the GDA I can see that I can get array size, get the data type, get the size, get the value, and we can set the value. And now we are almost good. So the value is gonna be the scale min. So what we want to do is to take our min cube, which is here, takes the x component and connect it. And you can see as the set needs to be generic within Golem, because sometimes we want to set an array of integer. There is a make array which automatically makes a conversion, takes the 0 component and makes it an array of just one component, which is just the x stuff here. But yeah, that's made automatically for you, but just keep in mind that the set requires an array because it's generic. We don't have just a set int or a set float or a set vector or a set array. We just have a set generic node. So this is why you need to have something like this. We want to do something like this too, so it's executed, and we want to do, so that's the mean value here, and let's do something similar for the max value. So I'm gonna bring that out, do a set value here, so it gets connected automatically, and I want to grab my x array here and make a connection. Not the best way to sort my stuff, but you get the idea, I guess. So let's compile this, make sure that I don't have made any error. So when you make a blueprint, it doesn't appear in your initializing scene. The only way to see what's going on is to press play, and now you can see you've got your characters which are twice bigger in terms of scale max, and the mean value is set to 1. If I was about to, want to control exactly what's going on, I can scale down my cube, and now my characters are different. Or scale up with a really wide number, and now I've got a really wide difference between my characters. So once again, it's really a silly example, but that shows you exactly how you can control those attributes, like isolate them, convert them, cast them into the right type, and set their value based on the different nodes that we can provide. Here, that setup is triggered when the simulation starts, but for some attributes which can be changed dynamically, you can use the event tick or other events that you have within Unreal to override those attributes. So here I'm using floating attribute, but you've got some string attribute, some int attribute, and the workflow is exactly the same. Rather than casting to a float property, you want to cast it as a string or as an int32 int64, and once again, that type is something you can get from the public attribute we're in Maya, or just from here, the simulation node, the float property that you had here. So yeah, hope that makes sense, and see you into the next video.